everyone. Thanks for joining us. My name's Samantha, and I'm the National Communications Officer for EHA. We're just waiting for our National President, Philip Swain, to join us. He's in remote Western Australia and currently connecting. So while we wait, I thought I'd give us a little bit of an intro into World Mosquito Day, which is actually celebrated on August 20th. So we are a few days late. So in 1894, Ronald Ross was a medical officer in the Indian Medical Service, and he studied mosquitoes as a likely vector for malaria. After years of fruitless research, Ross finally proved in 1897 that Anopheles mosquitoes could carry the malaria parasite. So he called this day of his discovery, the 20th of August, 1897, Mosquito Day. Now, World Mosquito Day is about raising awareness around the importance of mosquito and vector control in our communities. And this is something that's very relevant to any tropical countries in particular, especially tropical Queensland, where I'm currently based, Malaysia, the Philippines, Caribbean, and any other sort of tropical environments. Thailand is another very humid area where mosquito control is a concern. So today we're going to be hearing from two mosquito experts, one from here in Australia and one from in Malaysia, one of our partner countries as part of the IFEH Environmental Health Group. Seeing as we're having a bit of difficulty reaching out to Phil, I'm going to introduce our first speaker. So our first speaker joining us is Sathees Waran. Sathees is an Assistant Environmental Health Officer from Malaysia. So I'll join on screen now. Hi, Sathees. Sorry about tripping over your name there.
No problem with that. Thank you, Ms. Menta, and a very good morning to all the participants who are joining us live chat today. First of all, I would like to say this 8 o'clock morning in Malaysia, and let me introduce myself. My name is Sathees Waran, and I am an Assistant Environmental Health Officer from Malaysia, and currently I'm working in a Negeri Sembilan Health Department. It's going to be my 40th year of my service, and for a short briefing that my 10 years of my experience is on enforcement and the law and order of regarding on vector control. Okay, next. So today I'm going to talk about combating vector-borne diseases in vector control approaches in dengue prevention and control in Malaysia. Okay. As we all know today, more than 125 years later, mosquito-borne disease kill more than 1 million people and infect up to 700 million each year. That is almost 1 in 10 people. Already in 2023, there has been more than 3 million dengue cases and over 1,500 dengue-related deaths globally. As we all know, there are a lot of diseases that are vector-borne and which is caused by mosquitoes. But today I will focus on dengue concern in Malaysia because that is the major vector-borne disease that we concern in Malaysia. Okay. As I said, I'm from Malaysia, which is a country that famous of its tropical weather and also its skyscraper buildings. Other than that, we are also famous for our vector-borne disease, which is dengue. Okay. In March of 2023 itself, the dengue fever in Malaysia is on rise, which is on rise of 222.8% of cases compared to the last year, which is 26,222 cases compared. And as for death, it's increased to 17 cases from 4 cases from last year. And also we have recorded of 81 hotspots to indicate the outbreak area throughout the country. This is very concerning. And as our former Deputy General of the Health said, every level of society need to take responsibility and act proactively to reduce the incidence of dengue fever that is currently increasing. So the main objective of vector control in Malaysia is to reducing the burdens of vector population or the density to the level that it may not allow transmission. So we have few strategies on that to accomplish our objective. The first is the source reduction. In our term, we call it penghampusan tempat pembiakan. It also defined as search and destroy. The next one is larva siding, and space spraying, also we got thermal fogging, and targeted outdoor rescue spray, which is ORS, health promotion, and law enforcement. This is where I come in, which I've been implementing the DDBIA Act, which I will explain later, for almost 10 years. Okay, as you can see here, this is the one of the picture they're showing that they are carrying on the thermal fogging in resident area. Normally, we would spray this on dawn area, where around 5 to 7 p.m. in the afternoon, in the evening. Sorry. Okay. For the search and destroy activities, we have carried out a risk assessment to find out the mosquito breeding places. We also do door-to-door inspection, which means house-to-house inspection, ladies and gentlemen. Yes, we do that in the normally they carry out in the morning, where we go house by house and inspect their surrounding areas to search and destroy any mosquito breeding places. We also has a targeted high-risk premises, which we classified as contributing for mosquito breeding places as abandoned buildings, construction place. This will be highlighted as high-risk premises where the enforcement and the control measures will be carried out regularly and scheduled. So this is one of the example the insecticide we are using. It's been in a capsule. Okay. Okay. Also, I would like to highlight about a community program which we call it COMBI. The COMBI stands for Communication for Behavioral Impact. This program was pioneered by WHO and implemented by Ministry of Health in Malaysia. This is a from community, a by community to a community program. As you can see in the picture, the people are they are not government employees or authorized officer. They are local people, the civilians who participate as volunteers to raise the awareness of dengue control in the community uh, by themselves and for their local places. Okay, you may ask me what is the new innovative approaches in dengue control. As so far, I've been shared with you all the classic method. There are three strategies that I would like to highlight, which is one is the Wabasia mosquito program, the dengue forecasting, and the using of the drone in the dengue control. As we all know, the Wolbachia mosquito is where the intercellular bacteria injected in the mosquito to prevent the virus from multiply in the mosquito, so it cannot transmit the disease to when it bites human. Okay? And the dengue forecasting system is a system that forecasts dengue outbreak with sufficient lead time to allow for effective intervention to be implemented using seasonal climate data. This is like a prediction that we have come out with the analysis of the data for more than 10 years of data, where we can predict use of variables, we can predict outcoming outbreak and do the preventive measurements earlier before the outbreak occurs. These are some features I'm sharing with you that we have carried on our enforcement activities under the DDBIA, which is the Destruction of Disease-Bearing Insect Act. As you can see, we are inspecting construction area. We found some mosquito breeding places, and we identify the mosquito in the place itself, and maybe we can carry out some enforcement or some control measurement so that they can make sure the breeding places is destroyed or being taken care of. Okay, I would like to share some of my experience in using drones in the dengue prevention. Okay, we have in Malaysia we have some issues regarding on the water gutter. As you can see in the picture there, we have found that few mosquito breeding in the gutter. So it's hard to you inspect the place because it's high. So we use drone for the risk assessment, and we can identify the breeding places, and we take some preventive measurement control to prevent it happening again. So we have used it, but just it's implemented. Is now you can read about it in few researches and articles in online also. Okay, what is the role of assistant environmental officer in Malaysia in vector-borne disease control? Okay, you may heard from farm to table, but we are the one who transfer the data from field to farm. We do the investigation, collect the data, and the data collected is used for control measurement and also the enforcement. It goes vice versa. If any control measurement or the enforcement is failing or not effective, we go back to the investigation and collect the data again. On the evidence-based control, we take the what are the necessary measurements that required. And we all be familiar with the epidemiology triad. Connecting the dots is what I mean is vector here is also play the role as an intermediate host. Okay, the environmental health officer, the one who responsible to find the evidence and the sources of the outbreak and break the chains of transmission according to the epidemiology triad. That's why I always believe the environmental health officer's role or the assistant environmental officer role in disease control is very important because we are the one in the field and we are the one who know what the connection between the agent host and the environment. Okay, you may ask me what is next. Um, we all, as Sam said before, this is the mosquito day. I don't know whether we should be celebrating mosquitoes, but it's the mosquito is part of the ecosystem. We cannot deny that. They are also a living being who part of our mother nature. So, as for in Malaysia, dengue prevention and control is everyone's responsibility. Continuous efforts is required to sustain cooperation from communities in maintaining search and rescue activities. It's every stakeholder's responsibility to prevent dengue. And we also need a paradigm shift from control-based mode to preventive mode. This is we can done by evidence-based control, where whatever control measurement we have taken, we can analyze it, is it effective, or we can improve it to it can be more effective. There is no magic bullet in and a standalone tool to combat dengue. It's an integrated vector control management. And I would like to love to say this as my point of view. Nature always finds its way. You may heard it before in somewhere, but it's all about ecosystem balance. Whether we like it or not, the real threat here in vector-borne diseases is the virus itself or the parasite itself. Even though vector is an intermediate host, but our real enemy is the virus. If we try to reduce or control the organism that living in our nature, the ecosystem will be in balance. We're always looking for the equilibrium state of the epidemiology triad. So I always believe the perfect way to control a disease or outbreak is to get the ecosystem balance. So it will be a permanent solution. Otherwise, it's only going to be a short-term solution for me. And ladies and gentlemen, that's a few the short sharing with myself. And I would like to thank you once again, DHA, for inviting me from Malaysia to joining this live chat forum.
Hi, everyone. My apologies. Phil Swain here, National President of EHA, and I apologise for not being there to introduce Sathees. Thanks very much for your presentation, Sathees. I had some technical issues getting on this morning, so again, my apologies. And as you've indicated, you've got a bolt right now. We've got another meeting, so we understand that, and thanks very much. So thanks very much, and enjoy your day, Sathees, and thanks for coming along and contributing to our live chat.
Okay, thank you again, Phil. Thank you. Welcome.
But now we're speaking with Dr. Jonathan Darbro, who is the Advanced Medical Entomologist for Metro North Public Health Unit in Queensland, with Queensland Health. And he's also the President of the Mosquito Control Association of Australia. John has worked with mosquitoes for 20 years, having also been a research officer at both CSIRO and the Queensland Institution of Medical Research, Berghofer Medical Institute. Jonathan's interests include arbovirus surveillance, exotic mosquitoes, and integrated mosquito management. So today he'll be discussing how we control mosquitoes effectively and responsibly. Welcome, Jonathan.
Thank you, and thank you, Phil and Samantha and the EHA for the invitation. Happy belated World Mosquito Day. There's the slide. Next slide, please. Sorry, I had a bit of a technical difficulty as well, so I'm actually doing this through my phone, and Samantha is good enough to advance the slides for me. So what I'll be talking about today is what mosquito control looks like in I'm in southeastern Queensland, so that's My bias is going to be there, but the principles are similar across Australia. Sathees has given an excellent review of dengue control in domestic environments, and my focus today is going to be a little more on those freshwater and salt marsh environments. So we've got 3,500 species approximately of mosquitoes in the world, over 200 in Queensland. Most of them are not a problem. Most of them do not transmit diseases, are not a pest. So when we control mosquitoes, kill mosquitoes, we want to make sure that we're targeting only the ones that are causing the problems. Next slide, please. Why do we want to kill mosquitoes? I think we have a good understanding of this. Certain species transmit pathogens. In Australia, that means Ross River, Barmah Forest. Dengue, if you're in central or northern Queensland. More recently, Japanese encephalitis virus. Murray Valley encephalitis is another endemic virus. Malaria, we're reminded, is a possibility in Australia, certainly in the Torres Islands. There's been a small outbreak recently. Also, they're a huge nuisance. They cause complaints, and which means they can affect tourism, quality of life, that sort of thing. In Queensland, it falls on local governments to carry out mosquito control, and usually they are doing that in response to resident complaints. These are two of our most pestiferous mosquitoes in southeast Queensland. Aedes vigilax is a salt marsh mosquito. Culex annulorostris is a freshwater mosquito that's found all over the country. Next slide, please. Just a tiny bit more on these two species. Vigilax is it comes out after a significant rainfall or a significantly high tide, and a week or two after that. In large numbers, they fly very far. They're quite vicious. They're probably the biggest nuisance in southeast Queensland, especially if you're anywhere near the coast. They can also transmit Ross River and Barmah Forest pretty well. Culex annulorostris is found in freshwater environments, emergent vegetation, especially in sort of floodplains or agricultural fields, that sort of thing, which means it's all over the continent. And it can transmit a number of viruses, including Ross River, Barmah Forest, Japanese encephalitis, and also Murray Valley in the areas where those viruses are present. And it's another annoying mosquito. It's one of the species that can get into your bedroom and buzz in your ear all night. And so these tend to be, these environments tend to be our biggest priority, at least in southeast Queensland and in many places in Australia. Next slide, please. We follow the principles of integrated mosquito management, also known as integrated vector control, as Sathees touched upon as well. And when you're killing mosquitoes, you first want to identify what species you're looking at. That'll tell you where and when you want to target your efforts. You want to be carrying out surveillance early and often. You want to use every tool available. That can include chemicals, environmental controls like source reduction, biological control, also education, personal protection. You don't want to rely on just one tool. When you are applying chemicals, you want to make sure it's the right chemical against the right target species at the right time, at the right place, and in the right amount. Otherwise, you are wasting chemical, possibly causing unnecessary environmental harm, or you might not be applying it in the right way and not controlling the mosquito that you need to. After part of integrated mosquito management is evaluating your treatment after you do it to make sure you did correctly, that you killed the mosquitoes, and also managing insecticide resistance. I won't have time to touch on all of these in this short talk, but we'll see what I can do. Next slide. It's important to understand that in Australia, the primary strategy that just about everyone uses is to target the larvae. The larvae don't bite or transmit pathogens, so if you kill an adult, it may have already bitten somebody. If you kill a larva, it's never bitten anyone. The larvae are in predictable and contained locations. If you look at that bottom photo, they're going to be in the water, whereas the adults can be flying anywhere for hundreds or thousands of meters. Just logistically, you can imagine, much easier to target the larvae in the water. As it happens, our larvicides that we use in Australia have almost no non-target impacts compared to adulticides. So, for instance, we can treat natural wetlands with our larvicides, but we couldn't do that with our adulticides. And finally, if for whatever reason the larvicides fail, maybe it was really windy and they blew away, or whatever reason, you still will have a chance to control the adults before they cause nuisance or disease transmission. So a lot of good reasons to target the larvae. Next slide, please. Then we find the larvae. So the local governments who carry out mosquito control have a really good understanding of where the larval habitats are. You know, they have, in many cases, they have maps. So you go out there after an appropriate trigger. That could be a rainfall. That could be a high tide. And you look for larvae, and that's to make sure that you're not treating when it's unnecessary and that you're treating where the larvae are. Now we're on to this slide. I just want to talk about our two main larvicidal chemicals. The first is Bacillus thuringiensis israelensis. You can see why we call it BTI, huge name. It's a toxin produced by bacteria, so it is technically naturally occurring. It has what the crystal the bacteria produces isn't actually toxic. What happens is it goes in the water, larvae eat it, and then they have an alkaline gut, and that high pH activates the crystal and becomes a toxin. And what it does is it messes up the mosquito's midgut. If you look at those images on the right, the larva on the left side of that image is a normal larva. You can see a tube going through it. A mosquito larva is just a big gut with a body around it, and that's what a normal one looks like. If you go to that inset on the far right of the figure, that is a larva that has been exposed to BTI toxin for 6 hours. And if you look at that gut, it's just ripped up. It's got holes. It doesn't even meet up. And so you can see how much damage the gut takes in 6 hours. You can imagine that this BTI is quite toxic to mosquito larvae. But at the same time, it's very specific. It only affects certain insect groups, including mosquitoes and closely related black flies or gnats. It doesn't affect fish, doesn't affect pets, doesn't affect people, doesn't affect birds. It doesn't even affect bees or frogs or other sorts of aquatic insects. So it's a very effective, very specific chemical. It tends to be best against the really young mosquitoes that are only maybe a day or two old. So in Australia, if you see it can be applied multiple ways. You can do it through a hand sprayer. You can do it through a truck-mounted sprayer. Some councils will use helicopters. A few even use drones. If you see a helicopter spraying chemicals in Australia, that's pretty much always going to be a larvicide. We don't use aerial aircraft to spray adulticides in Australia. Next slide, please. The other main larvicide is methoprene. Those of you who do environmental health work are probably quite familiar with methoprene. It's what we call an insect growth regulator mimic. So it affects the hormones that insects use to metamorphose into the adult form. And so you can see that there are a couple photos down there of affected mosquitoes. On the left, you have a larva that while it attempted to turn into a pupa, but because of methoprene, only did it about halfway. So now it's sort of a half larva, half pupa. So it's going to die. And on the right is an adult that's trying to sort of metamorphose from pupa to adult, and again it got messed up because of the methoprene and died. So it's another effective tool specific to certain insect species, including mosquitoes. Also affects it also affects things like fleas. They use it in flea control. Doesn't affect honeybees the way we apply it. And it tends to be more effective towards those older larvae that are about to turn into a pupa. So if your BTI, for instance, doesn't work, you might have time to try methoprene. There are a lot of formulations that methoprene is in. Those briquettes in the top photo are good for, say, rainwater tanks. Some people might be familiar with the pellets. They're really good for a range of applications, like rain gutters or catch basins, that sort of thing. There's also sand and granular applications. Next slide, please. Now I'll talk a bit about killing adult mosquitoes. It's not done as often in Australia because we aim for the larvae for those advantages that I talked about earlier. But sometimes you need to kill adults. For instance, to stop virus transmission. Sathees talked about dengue control. If we have an active dengue outbreak somewhere like Cairns or Rockhampton, killing the larvae isn't going to do anything about those virus-filled mosquitoes that are flying around right now. So you have to go in there and you have to kill those adults. When we want to kill exotic mosquitoes that show up at the airport or the seaport, we want to use everything we can to kill them, to kill all of them, so they don't become established in Australia. So we use adulticides. Sometimes vulnerable populations need to be protected, maybe at schools, maybe at aged care facilities. Conceivably, if you have huge numbers of mosquitoes that are causing a lot of problems, you might want to do something quick to knock them down. Like this photo here, I think it's from Alaska, of how big those mosquito numbers could get. Next slide, please. There are a few adulticides that we have access to in Australia, but the most common ones by far are what we call the pyrethrins and the pyrethroids. Pyrethrins are extracted from the chrysanthemum flower. They have a very, and pyrethroids are synthesized chemicals based on what the pyrethrins look like chemically. And they do that to give them a bit more stability and residual life. The way they work is they're nerve poisons. You have a nerve cell, it fires, and then and the receptors reset. And the pyrethrins and the pyrethroids inhibit that resetting. So if you ever killed a fly or a mosquito with bug spray, you can see it has all these sorts of behavioral weirdness before they die. They walk funny, they try to fly, but they spin in a circle, that sort of thing. That's because their nerve cells are going haywire. These chemicals are broad spectrum because most animals have the same kind of nerve cell. So you have to be really careful how you apply it. All insecticides have a label with instructions for how, and legal instructions for how you use it. You have to follow that label. For the pyrethroids and pyrethrins, for instance, because these chemicals can be toxic to fish, you never apply them near water. Because they're toxic to honeybees and native bees, you don't apply them around hives or around bees or when plants are flowering, when bees could be there. Next slide, please. So how do we apply adulticides? The two of the main ways, one is residual spraying, and probably the more common adulticide application in Australia. You spray a surface with the chemical, and the surface dries and it stays there usually 4 or 5 weeks, and it kills mosquitoes that land on it. The nice thing about mosquitoes, they're small, so it doesn't take a lot of chemical to kill them. And so you might see that in what they call barrier spraying walls or vegetation. And for instance, there are pest control companies that you can hire to do that around your house. But also for dengue control, you often see indoor residual spraying inside houses or kind of under the Queenslander under area of the house or around fences. It's a sort of thing, for instance, that Sathees would have talked about as a major way of controlling those dengue mosquitoes. Next slide, please. You do have space spraying, and that's what sometimes people refer to as fogging. And that's when you have mosquitoes in the air, and you just want to kill the mosquitoes flying in the air right now. It's not used very often because there's no residual life to this chemical. So you spray it, you kill whatever was in the air at that instant. Later that day, more mosquitoes will come in, and they won't be affected. You're usually using something like a pyrethroid or a pyrethrin. So that's going to be a broad spectrum. Any insect flying in there is going to be affected by that insecticide. So you want to be careful, and you need to do it at a very specific time of day. If usually just sunrise, just after sunrise. Otherwise, it gets so hot that the chemical lifts and dissipates and is no good. So if there's certainly times to use it. If we had an outbreak of something serious like Japanese encephalitis virus, and we knew there are mosquitoes flying around infected with a high risk of biting people, we would consider something like this to knock them down. At the airport or at places around the seaport, if we think there's exotic mosquitoes flying around and we want to kill them all, we'll fog an entire warehouse or the baggage tunnel underneath the airport. So there's certainly uses for that sort of thing, but it's not very often. Next slide, please. So in conclusion, I've really just scratched the surface of mosquito control in Australia. I'm sure there are actual mosquito control practitioners sitting there thinking, oh, he missed about 200 things, and I did. But the principles are there. Integrated mosquito management, we're using as many tools as possible, both chemical and non-chemical. Surveillance is critical. Monitoring is critical. Most of the control, most of the chemicals we're doing is targeted against those larvae. And because our larvicides are safe, and they have minimal, virtually no non-target effects, but they're really good against mosquito larvae. Adulticide is less common, but sometimes you have to do it. There are applications for it. I could have given an entire talk on insecticide resistance and resistance management, but just to remember, we don't actually have a lot of different chemical modes of action that we have available to use. And so it's very important to keep an eye on that resistance so that currently Australian mosquitoes, everything works on them, and we like to keep it that way. Finally, thank our mosquito control teams out there, the local, in some cases state guys who are out there controlling mosquitoes. Even if, they're easily, if you think there are a lot of mosquitoes out there, remember they're killing over 90% of them. Next slide, please. So this is what your feet might look like if it weren't for our excellent mosquito control teams. Well, thanks everybody. Happy to take any questions. Happy Mosquito Day.
So thanks everyone for your attendance. Lastly, if you'd like more information on environmental health officers, or Environmental Health Australia, the organisation, visit our website and follow the links in the comments box. Also, so please see our site for information and call for papers for the International Federation of Environmental Health World Congress on environmental health, the 20th to the 25th of May next year in Perth, Western Australia. If you're engaged in research or you've got an interesting, pragmatic, practical project that you'd like to share with us, then please submit a paper, an abstract on your paper, and we'll be keen to have a look at it. We're definitely chasing national and international content for our World Congress in May next year. But thanks everyone for joining us, and have a happy and somewhat belated Mosquito Day. And again, apologies for the technical difficulties that we've had today. Thanks everyone.